Alright, guys, we're live. Now
Cool.
just to hope that everything like it should.
Right.
Did you guys have any questions on work?
So was it like a review, or were there some new concepts? 'Cause, I mean,
Or
I
the,
looked at it.
not the homework, I meant the preparation assignment.
Right.
And it seemed like it was kind of a review, but at the same time, there's only one question I didn't know how to do from not before.
Right.
Well, I'm still wondering. I don't know for number 3 question with the B. I don't know where they pulled the part. I'm looking at the answer key and they got 0.25335. You're multiplying that by the 10 minus 5. I don't know where they got that from.
Wait, what?
Number 3 on the homework, letter B. The 10 minus 5 I understand, but I don't know where they got the 0.25335 to multiply that back
I don't know.
from.
Give me just a second.
Oh, okay. I was looking through the homework and I couldn't figure it out. I was reading and I couldn't find anything about it.
Here we go. Which one was it? The D?
Letter B?
Letter B, the percentile, right?
Yeah.
That's the one I don't know how to do either, so I really can't tell you.
Okay.
Yeah, 3 was kind of weird. Like, you just,
Like, I don't know. I didn't understand.
I mean,
like, all of question 3 I really didn't understand. Except for A, that one.
Yeah, it was pretty straightforward. Or 1.
So D and, with D and E, I didn't know exactly how to do it with the graph thing. I didn't know exactly.
What you do is find the z-score. So you do like the 12 minus 10 divided by 5 and find your z-score. And then the z-score that gives you plug in. And since you want greater than 12, you do the greater than whatever the z-score was you found. So like if you found a positive z-score, it'd be above the z-score line. If it was negative, it'd be the middle section and the top section. So I think I got the right answer.
Did you need the graphing applet for that, or could you just figure it out in the numbers?
Graphing.
You needed it.
Oh, okay. I'll just pull that up then.
I mean, there's it otherwise. It just takes a really, really, really long time to do it.
What? Is the graphing applet, is that in lesson 6?
I thought it was 5.
5?
I don't know. I saved it to my toolbar.
Oh, okay. Let's pull that up really quickly.
So I got the rest of the answers for number 3 right. I just don't. Yeah, where is this 0.25335 coming from?
Right.
I wonder if that's the. If I type it in. Let me see if I can find. Have you guys figured out where
The which one?
for the 40th percentile where the random number that she multiplies by comes from?
Oh, no.
40th percentile. Crap.
Yeah, lesson 5 is where the probability applet was.
No, I still don't know what you got that number from.
I don't know. That's why I'm looking at past lessons to see if I can find where percentile.
If you're using the applet, I mean, if you want to find the 40th percentile, do you just you type in 0.4? Is that how it works?
No, that changes the Z.
That's what you'd think, but 40th percentile for this population. But what exactly is the sample mean so we can finish the z-score to find the to get the rest of the mean so we can, there are 40% in there.
Right. It's true. Let's see. Just so I'm with you guys. What did you guys get for 3A? Just kind of.
I got 8.27 or like 68.27%.
It's just
Okay.
the 68% going.
Oh, okay. So, and that's where you do use the applet, right?
Yeah.
Okay. Here we go.
Once we can figure out where the percentile thing comes in, I think it would be a ton easier, but where the percentile stuff.
Yeah. Oh, wait.
I'm beyond lost as to where she got this number from.
I really don't know. There's no explanation on it.
I tried typing in the 40% into the probability applet where the z-scores were at 1, and when it changed, it said the z-scores are now like 0.842, which is pretty close to the population thing, pretty close to the answer she got, but I don't know where her answer is coming from.
Right.
That's the only question I have. I don't know if we're going to do anything with that.
This is super confusing and frustrating.
Yeah.
I don't understand.
So where did we learn percentiles? Percentiles. See, what lesson did we learn about percentiles? Was it 5?
I don't know. I went all the way back through lesson 3 and there was nothing.
Uh-huh.
So now I'm it.
Yeah. Yeah, because it's exactly like you said. It's like finding out that 40th percentile. It's just I have no idea where that 0.25 comes from.
I really hope it's not on the phrase.
It's what?
I really hope it's not on the phrase that.
Yeah. Yeah. No.
Here's a question, just randomly. Do we have tests in this class or no?
I'm assuming so, but I don't know when they are.
Because I haven't found them. I haven't seen them.
So it looks like from this online textbook I found, it says to find the percentile, you do the number, we want the 40th, 40 out of 100 times the amount of numbers we have plus 1.
Mhm.
So does it give us how many numbers are in the sample?
I don't know. Yeah.
Because where it's coming from in the text, or in the area of the preparation assignment, it should be in the chapter we just read. Only it's not there.
And I just looked at the PowerPoint from it too. That's not in there either.
There's PowerPoints for this class?
Yeah. It's under the resources tab.
Yeah.
Each section has one.
Have you guys watched the videos on this? Because actually, I didn't get a chance to watch them yet. Maybe it's got something there.
No,
Go actually watch it.
Oh, just kidding. Our first exam is next week, guys.
Where'd you see that?
Under week 4. I accidentally clicked it when my computer is being too slow.
Oh. Interesting.
Oh, there it is, yeah. I'm not ready. I don't know. I'm not quite ready for that.
So to find the 40th percentile, do you need a z-score first?
That's what I'm trying to figure out, if that's a z-score or not, because I have no idea where this 0.25 comes in.
Right.
Well, I'm looking at it. It looks like they just typed it in. I'm looking at the videos that talk about how to walk through them and stuff.
Mm-hmm.
They typed in the apple and that number popped out. So
What number? What did they type in though?
they typed in the 0.4.
Really?
Where is it?
Because I typed in 0.4 for that too, but I didn't get that answer.
The 2.53.
Yeah. 0.253. Yeah, that's what I got too.
What did you guys leave as the z-score when you typed in the 0.4?
They just
Typing in 4
changed
as the z-score.
It changes. Yeah, it changes automatically. So you put the 0.4 in the area box, and then the z-score will compute itself. And then we got 0.253. Oh, yes.
So the percentile we just type into the top thing.
I guess so. Yeah.
Let me see. I'm gonna try this.
Well, now that we figured it out.
Oh, thank goodness.
Well,
I'm typing in, but it's not working. I don't know what's happening. Oh, okay. Now I figured it out. You have to have the left side flipped because we're looking below the 40th percentile. Now I understand.
wait, what?
Because I didn't have the right part shaded in because you're trying to look for the lower 40 percentile.
Mm-hmm.
In the area, it's 0
Okay.
to 1, so that's you can go 10, 20, 30, 40%. So when you do the 0.4, you're
So
finding
it's the very
40%. And then you find the left
area
side.
that's not shaded.
Yeah. And that's where you get your 2.53.
Yeah.
Okay, that was a little confusing, but
Yeah.
now I got it.
So before I type it in, before I type in the 0.4, I want to make sure it's just the bottom area that's highlighted.
Yeah, the left side of the line.
Yeah.
Okay, I see now.
Now you got it?
Yeah.
Yep.
Well, makes sense.
Oh, Olivia.
Well, we're gonna go over something else. Or...
Was there any questions for part 2?
I think they wanted us to do that as a group as well.
Okay.
Okay, well, we can go through it real quick if you want.
Yeah, that'd be good. That'd be helpful.
So, let's see. Suppose pair computing sold an average of 45 P phones per minute in 2011 with a standard deviation of 10. They looked at their P phone sales data and determined that it is normally distributed. So samples of size 4 are taken from the 2011 sales data. What is the shape of the distribution?
Oh, just
This
normal.
was normal because it said it was normally distributed.
Yep.
Oh, okay.
It's normal because the pair distribution was normal.
All right.
5's the same thing.
So in the number 5, it's samples of 40 are taken from that amount of data. What's the shape of the distribution?
Normal.
Next, a sample of size 4 is taken from the distribution in 2011 sales data. What is the probability that the observed sample mean is greater than 40?
What's the probability? You figure that one out. Sample size again.
The answer should be like 1.6, I think.
Yeah, that's what it is. And how? Yeah, sorry, but how did you get that again? The 1.6.
Well, I got what the answer key said the answer should be.
Right.
Oh, for number 6?
I got like 87 something.
0.16? Yeah, but I don't know how.
Right.
If you're using that formula they're supposed to use, it'd be 40 minus 5 divided by 10 divided by the square root of 4, which would give us -1 for the z-score, and then you plug that into the little app.
Oh, got it. Okay. Keep forgetting the applet. Got it. That makes sense.
So,
In the applet, it's like 0.1587, but just round it up.
Which would round to 0.16. Okay, that makes sense.
Okay. I gotta learn how to use this applet. Keep forgetting.
Alright, on to number 7. A sample of size 4 is taken from the distribution, from the normally distributed 2011 sales data. What is the probability that the observed sample mean is greater than 35 and less than 55?
Oh, right. Information's right there.
That would be the 0.0228.
No, because you're going to want the area of the
greater
middle
than
of the
35. Oh,
probability.
greater than 35 and less than 30. So it's in the middle. Got it. Yep. I didn't have the right price by then.
Then again, the numbers that it gives you, that's within 2 standard deviations of the mean, just around 95%, right?
Yeah. Nope. There's the number 8 too.
So what was the z-score that you got for that?
For which one?
Uh,
For 7?
Yeah.
Moses one.
I got 2.
Negative. Yeah.
Yeah, 2.
2 and -2.
Mm-hmm.
Which would tell us within a couple standard deviations of the mean. If it's 2 standard deviations away from the mean, then wouldn't it just be 95%?
Yes.
Using the 68, 95, 99.7 rule?
Yeah. Just... Okay. Crap! It's like so many of those equations I've just forgotten which ones to use. So I'm still trying to figure that out, how to do it. 4.
Yeah, it gets a little confusing.
Yeah. Okay, so what equation did you use for number 7?
What you do is you take the I just always the biggest number, so I did 55 minus the population mean that it gave us of 45.
Oh, okay.
And then you divide that by the standard deviation.
Okay.
But the standard deviation is divided by the square root of the sample size.
Square root of the sample size?
Yes, so it'd be like 55 minus 45 divided by 10 divided by 4.
Times, divided by 10? Sorry.
Yeah.
Okay.
Because the entire denominator would be 10 divided by the square root of, or 10 divided by 2, which is 5.
Okay.
But that just gives e-score, and then you have to plug it into the applet.
Right. Oh, goodness.
Did you get it?
No, I getting something different. So I did 55 minus 45.
Mm-hmm.
Gives me 10, and then you divide that by 2.
Yep. No, you divide that by 5.
Divided by 5. Oh, okay.
Yeah, because 5 is 10 divided by the square root of -4. Or of square root of 4, which is square root of 4 is 2. 10 divided by 2 is 5.
Okay. And
And then you have the 10 on top from the 55 minus 45. And so you have that 10 divided by 5, which gives you 2.
okay. Okay. Do you know where that equation is in the online textbooks? Is that chapter 7 or
From lesson 7.
lesson 7? Oh, okay. All right, that makes sense. Okay, yeah, I got it.
And then you're just using that exact same equation for number 8, but different values.
Okay. Let me give that a go. Number 8. So 49 minus 45 gives me 4. What? Oh, what the frick?
What?
Just following the formula. It's like I got the same answer as 7, but let me just try that again.
We'll make sure that you use the n as 25 this time instead of 4.
So oh gosh, all right, yeah, you're right.
It would be 49 minus 5 divided by 10 divided by the square root of 25.
Yeah. Okay, so 10 divided by square root 25. I get 2.
Yep, that's right.
Oh, it's 2. Okay.
Yeah, so that should tell you that you're going to have the same answer for 7 as you did for 8.
Oh, okay.
Or
Okay.
as you did 7.
That's right. Okay, cool. That's what I got the first time. I just wasn't sure. All right, cool. Makes sense. Okay. Sample size 25. It's greater than 50. Okay. So I'm gonna try number 9 now. 50
Okay.
minus 45. See, I got 2.5 for 9.
As the z-score, yeah.
Oh, it's a z-score. That's right. And then I gotta plug it in. That's gonna be greater. Enter. Just check the answer key, make sure I got that right. I know he did. Oh, cool. All right, I got it. 0.0062.
Yep, that's what I got.
Awesome. Looks like the rest of the questions are like 10 through 15 is like the same thing almost.
Yeah, they're just repeat.
Pretty much.
Just more review.
Oh, cool. All right. Awesome.
You guys ready for the quiz then?
Yeah. Let's do it.
Well, the first question is pretty easy. So, you guys in already?
Okay.
Yeah.
Yeah, I'm ready.
I'm here. I'm ready.
Yeah, I think I got the answer to the first one, but you guys should do it first.
Find the combined area under the.
Type that in. It was 1.358, right?
Mm-hmm.
For number 3?
Yeah, for the z-score.
The z-score, yeah.
And we're finding on the 2 outsides of it?
Yeah.
Yeah.
Okay. What'd you guys get?
175.
0.175. Yep.
Yeah, that's what
All right, cool. Want me to read number 4?
Sure.
That one. All right. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in the sample. Round your answer to 3 decimal places. And the note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction. Whatever that means.
That just means the same thing we did for the number 3. We're finding the one to the left of the middle area and the one to the right of the middle area, but not the middle area.
Oh, okay.
So it looks like we're just finding the z-score and then finding that area, basically.
Okay.
And it gives us all the information to actually find the z-score this time.
Awesome.
Okay, I think I have the z-score, but let's see what you guys do.
I got 0.2771 for the z-score.
Maybe that's not what I got. So, how exact? What did you put in?
What'd you get?
I got 1.92018.
Oh, just kidding. I did that backwards. I got negative 0.277 this time.
So what did you put as the number? Just the order of them. Because for the top of the equation, I did the 177.6 minus the 185. And then I did the 26.
Yeah, that's what I did.
26.7 divided by the square root of 48.
Oh, yeah.
Oh, I did. There was a...
You did what?
How many... What was the sample number? I didn't catch that part of the question.
48 commercial boats.
Oh, sweet. Okay, I got that one too.
So 1.92, right?
Yeah, so negative 1.92.
Oh, awesome.
So that's the z-score.
Yeah. Which gives us a probability of about 0.055.
Yeah. Well, is it to 2 or decimal? Is it 3 decimal
To
points?
3 decimal places.
3 decimal places, yeah.
Oh, there's the 0.0. I didn't see that. Okay. So yeah, 0.055.
Awesome.
All right, which of the following will have a smaller standard deviation? 9 observations are randomly drawn from a population. The distribution of the individual observations of X, the distribution of sample means of X bar, or this cannot be determined from the information given. I'm feeling C.
Yeah.
Because we have no way of knowing if the standard deviation is going to be small or large.
Which of the following is smaller?
Is that
What?
I don't know. What makes you say that there's not enough
I feel like
information? Well, what else would we need? Because individual
because
observations are usually skewed because it just depends on where you're at, right?
yeah.
So we do a sample mean, wouldn't the standard deviation be lower? Maybe? I don't know.
Well, the sample what you have to have both the population mean and the sample mean in order to find the z-score, and the standard deviation depends on the data set.
Okay. I can agree with that. Because 9 observations isn't that many.
What?
Because it tells us that there's 9 observations, but that's a really low number. Because isn't it like, you'll know the standard deviation would be better with the more that you take. So you won't really be able to tell, I guess, maybe.
That's the thing, though. Standard deviation depends on the data set. It doesn't depend on the number of observations.
Okay.
The number of observations will change the z-score, but not the standard deviation, right?
Mm. Well, I don't know. I'm okay with that.
Wait, with which answer?
We put C, didn't we?
Yeah, I was sure that it didn't get changed and I missed it or something.
Okay. And 6, that's A, isn't it?
Which of the following implies the spread in the X part increases? Let's see. Well, as the sample size gets bigger, the distribution itself becomes more normal. But I don't know about the spread in the X stuff. Is that part of the law of large numbers?
It could be.
Because under the central limit theorem is that the distribution becomes more normal as the sample size increases. And so I'm assuming that the spread in X will decrease with the law of large numbers?
Well, law of large
I
numbers,
really
it says, is whether describes the result of performing the same experiment a large number of times. They're kind of similar, but they're not. I remember reading about it, how they say, like, we always confuse them all the time. They're the same, but not the same. So it's kind of confusing.
What does it mean by the spread in X, though? Does the spread in X just meaning, like, there's more there?
No idea. Sometimes the spread.
Do we want to skip him back to it?
That's fine.
All right.
Well, is Cameron? He's not here anymore, is he?
What?
Cameron left. He's not in the call anymore. Do you know what happened to him?
Oh, that's no bueno. I have no idea. I didn't have that window pulled up, so I have no idea what's going on.
Well, he was quiet for a while, and then I just checked, and well, he's not there. That's weird. He's not online, so I guess we just keep going.
I can
Let me get my charger from
try
my bag.
inviting him back. What? All right, well, I tried inviting him back. I don't know what happened, though.
But he's back online now, right?
I don't know.
Yeah, he is.
He's not back in our video yet, but...
Yeah, he isn't.
Hey, sorry, some connection was lost.
Hey, that's all good. We're just making sure you were still good.
Alright. Cool. Right. Okay. So, what was 5? Sorry for that.
Say 5 was that it can't be determined from the information given.
Okay. Sounds good.
And then for 6, I don't know.
6 we're confused on.
Okay. Okay, so it's certainly not the 68, 95, 99 rule.
Yeah, it's not.
Not that.
A normal distribution isn't really anything that just describes what it looks like, isn't it?
Right.
Yeah.
The spread in the export decreases as the sample size increases. See, because the law of large numbers, that's like the more samples there are, like the more data there is, like the more like normal it becomes. Is that what it is?
That's the central limit theorem.
Okay. So
The law of large numbers kind of talks about it. It's just doing the same thing over and over and over again to see what happens.
Right. The law of large numbers, that's talking about like equal the mean with the more numbers there are. Or is that, let me find that.
I think so.
Yeah. Large numbers. Alright. Spread and export decreases, sample size increases. I don't know, yeah, it would almost seem like that would be the normal distribution. I mean, but yeah, again, I could be wrong.
Yep. So do we want, so is the lowers or is it the central limit theorem?
Yeah, I'm looking that up. I can't find it. 6, I think.
So it says law of numbers is a principle of probability and statistics which states that as the sample size grows, its mean will get closer and closer to the average of the population.
I worked for 3 hours, and then I have a half-hour break, and then a class for an hour and a half. So basically, Tuesdays and Thursdays, my life is filled.
Yeah.
That's pretty much my whole day gone.
It doesn't seem like exactly what it's asking.
Yeah,
No.
already
The
1:15. I can have
I don't think that's it.
If I were Connor, I really hope.
I don't think it's going
Because the spread is just,
Like, not on purpose. But, like, I really hope. Like, oh gosh, honeymoon baby. Crap. And then you guys have a baby. And then you realize, oh my gosh, when I was complaining about accidents, 115.
I feel like the law is the right one.
115 in the 40.
The law of large numbers?
Crap, I gotta go to work.
Yeah,
I have
That makes sense.
Yeah.
because
Because
when I read it, the principle of probability, that it states that as the sample size grows, its mean will get closer and closer to the average of the whole population. So the spread, meaning like how wide it is, down, meaning the mean's getting closer to the average, right?
Homework hangs over you. It's like a lightning.
Sorry, I didn't hear anything you said.
Homework.
I kind
Don't go over your homework.
of.
You're a fag because you just sit there and do me all day.
Okay.
I was like, I don't know. I feel like it could be almost anything.
You should.
The law of large numbers.
Whatever you want.
I'm pretty sure it's not normal distribution.
Right.
And central limit theorem, I'm almost positive that's not right either.
Uh-huh.
Okay.
Let's go with
That's
the
fine. We can just go with B.
large numbers. Okay. Let's do that.
We're good to go with the large numbers then?
It's number 7.
All large numbers. Yep.
Yeah.
Alright, I'm good.
Okay.
Scores on the quantitative portion of the
see.
GRE are approximately normal distributed
Number 7.
between 150.8 and standard deviation of 8.8.
Like we're just pretty simple.
Finding the
60
score.
on the quantitative portion of the calculation is 150.8 and standard deviation is 8.8.
Yeah. Minus.
So which one's N? I can't find that out. You're supposed to take the square root of something.
You don't need,
You don't need to do that?
because in this one it's just 160 minus 158.
Okay. So I got 1.045.
Yeah, I'm still plugging this in.
1.045. Just the 160 minus. Yeah.
Oh my goodness gracious. Okay. Okay, so 160 minus 150.8. 9.2 divided by. Okay, what the heck? Alright, so. Okay, so what I'm doing for this, I was doing 160 minus 150.8. Is that
That's
what
the
you guys
first
did?
part.
Minus 150.8, yeah.
Okay. Then.
And then they just got it.
That's the 8.8.
Oh. Okay, so yeah, I'm getting like 1.045. Okay, for the
Yeah.
Yeah, that's what I got.
Okay, alright. Just making sure. I have to try to use the applet.
And then for this one, I got 0.148.
That's what I got.
Mhm.
One. Alright, 1.045. Okay, and that was a z-score. Okay, so 7. And then for 8. Oh, 16. Did you guys get 8 yet?
Yeah.
Okay.
Yeah.
So is it 0.148 or what
Yeah.
is it? Yeah, that's what it is.
0.148.
Okay.
Looking at the next one, I don't know exactly what to do.
Number 9.
Yeah.
So what you do is you take the 5 numbers and you find the average of them, which I think it turned out to be 160.
Mm-hmm.
Just find the average.
And then you take that and you subtract it from the population mean, and that's when you use the standard deviation divided by the square root of n, which is 5.
Yeah, so it's 160, and then you do
So you do 160 minus. Wait. Oh, wait.
So I got 2.337 to 2.338.
Yep, that's what I got.
Okay. So what? Okay. So I'm still at the. Okay, so you got the averages of all those 5 samples, which comes out to 160.
Mm-hmm. And then you take that and you say 160 minus the population mean, which is 150.8.
Oh, okay. Right.
Yep, and then you divide it by your deviation divided by the square root of n.
Okay.
It's like what you wanted to do for number 7, only there was no n to use.
Right.
On 7.
Square root. Okay. 8.8. Square root of. So 8.8 divided by the square root of the.
Of n, which is just the number of samples.
Oh, okay, 5. Okay.
Yeah.
There we go. Okay, so I get 2.33. Let me plug that in. And then we want more. Okay, got it. So 2.
So number 10 is the probability students will have a that 5 students will have a mean score higher than 160 using the scores from the previous problem. So you're just putting that z-score in and finding the area to the right.
Okay.
And I got 0.009.
Yeah, that's what I got.
0.0097. Okay, that's what I got too.
Yep.
Awesome. All right, I'm number 11 now.
Well, it's just talking. Suppose the mean GPA of the students here at BYU Idaho is 3.5 and the standard deviation is 0.7. It's well known that the distribution is left skewed. If you take a random sample of 81 students will be drawn. So with the shape of the sampling distribution of the random variable x, which represents the sample mean of 81 students who are selected.
And to be approximately normal.
I would say. Yeah, that's what I would say too, because it's a pretty large sample size.
Yeah. I agree. What is the mean of distribution of sample means?
What is the mean distribution?
Okay. What is the mean of the distribution of the sample means, sampling distribution for all possible samples of size 81 that could be drawn from the parent population?
So it's just asking us what the sample mean is to go with the population mean.
Would that be the 3.5?
And I'm not really sure how to do that one.
Mean.
What was it approximately?
Huh?
Wait, what?
I don't know, I'm just thinking.
Oh, okay.
Oh, is this 3.5 minus 0.7 using the z-score? Where we find the z-score for the... No, because this isn't a percentile, just kidding.
What does it mean, the distribution?
I remember doing some problems that are kind of like this, but like the answer was in the question. Like at 13, for example, it's asking like with the standard deviation of the sampling distribution, the random variable x bar, would that just be 0.7? That sounds a little crazy, but I don't know.
No, the standard deviation, you would take the 0.7 divided by the square root of 81.
Oh, right, okay.
Is that what we're supposed to do?
For 13, I don't know about 12.
Right.
Oh, that's for 13?
Yeah, that one was for 13. Mean of the distribution of the sample means.
Well, I don't know, I'm feeling that... I don't know, is there any calculations we're supposed to do for this?
I'm not sure.
The mean of the mean should be, if you have 81 people, the mean should be approximately 3.5 because it levels out pretty quick.
Yeah.
I don't know if I'm...
Wait, how'd you get that?
Well, just looking at it, it says like the GPA, the average is 3.5, and well, just the mean. That's just the mean. If that's the, because it says suppose the mean is 3.5. At 81, the mean should be leveling off by that point. So it could be just the 3.5 as it is.
Yeah, because I mean, because the higher the number is, the higher the samples are, the closer to the mean it would be. So, because
it looks like based off of that there's actually calculations because we're supposed to round our answer.
Yeah. Yeah, because for 13, like I got like 0.007777. Just rounded up to 0.008.
0078.
Okay. Yeah.
0.077. Wait, mine is, I got 0.077.
Yeah, that's what I got too.
Yeah.
So we just put the 0.078. But I have no idea what we do for 12.
I mean 3.5 could very easily be right because we don't have any more information to the sample mean off of. But usually 3.5 would be the population mean and not the sample mean.
Well, I don't see what we could do to figure out the answer. We don't have any numbers. Okay.
Yeah, I would just go with that.
Well, we could plug it into the formula and just rearrange the formula because we have the z-score and we have our standard deviation before n and we have our population mean, so we could find the sample mean.
All right, that's a good idea. So let's see.
I don't know how we found z-score for this thing.
I say solve like 3.5 is 3. Like the answer is probably 3.5, rounding wise.
Mm-hmm.
It does say round your answer to 1 decimal place, so.
Yeah, that's what I got.
Yeah.
We don't have the z-score yet, do we?
Yeah, we do for 13.
For 0.071?
Isn't it?
That's the standard deviation. I don't know if that's the z-score.
I say 3.5 is still the right answer, though.
Yeah.
And we already did teen and got that one.
Well, if we're doing what we did, I got my answer to be 46 for number 14. What? 4, 6, 8, 9.
What?
For 14?
14?
Yeah.
I got 0.0052.
0052. Hold on. Oh, I changed some stuff on there. Hold on. Oh, where'd you go?
Less than 3.3. So, okay, so less than right. So did you get? I got like 0.0051 for the
I got 0.0052.
maybe.
Hold on, let me recalculate. I think I might have done something wrong.
Oh, sure, I'll check something. .57.
Yes, definitely. Oh, you're over here? Oh, okay.
Yeah. Well, I mean, if we're running into 3 decimal places, it would just be 0.005.
That one you round to 4.
Wait, we're putting the 0.078 as the z-score, right? I'm so confused on what's going on.
What?
We're on 14 right now, right?
That's what I'm on.
You were right. 0051.
Yeah. Well, wait.
Well, how'd you guys get to that?
We typed in the z-score.
Well, you take 3.3 minus 3.5, and you divide that by 0.7 divided by the 81 square root of 81.
Divide the 0.7 by the square root of what?
Square root of 81.
Of 81, yeah.
Oh, okay, yeah. Oh, okay, no, what I did. So then the answer should be the negative 2.57.
Yeah.
Yep, and then you plug that into the applet, and it gives you
The 0.0051.
Yeah.
Yep.
Which for the answer would just be 0.005 because you're rounding up to 3 decimal places.
Yeah. And the next one is just.
And then 15, you're just finding.
That should be the 0.99.
Yeah, it's the same thing. You just highlight. I got 0.995.
Yeah.
0.95?
0.995.
0.995.
0.995.
Yep. Yeah.
Cool. Holy crap, we're done.
That one took a while.
Yeah. I think I get it a little more now, so it's one good thing. Alright. So here I'll just go over the answers.
That's pretty good.
Yeah. So 3 is
Okay.
Question 3 is 0.175. Question 4 is 0.055.
Okay.
Question 5 is the third option. 6 is the first option, the law of large numbers. Question 7 is 1.045. Question 8 is 0.148. Question 9 is 2.338. Question 10 is 0.0097. Question 11 is approximately normal. Question 12 is 3.5. Question 13 is 0.008. Question 14.
0.008?
For 13?
Yeah.
I got 0.078.
Yeah.
Oh. 0.078.
That's where we go.
Yep.
Oops. Okay. Alright, got it. Okay, 13 is 0.078. Question 14 is 0.005. And question 15 is 0.995.
Yep.
Alright. I'm going to press submit.
We missed one.
Oh.
We missed the one. We missed number 5.
We missed number 5.
Yeah.
Awesome. Okay.
I'm still
Holy
working on
crap.
that.
Man, I did really well. Whew. Holy smokes.
Yeah.
Alright. Well, thanks for your help. I feel like I get it a bit more now.
That's good. Was
Mhm.
hold on. My computer's stupid. No, we got that one right. Okay.
No, it was
So
the
I
one that we
can-
couldn't determine it.
have been the individual observations. So there's probably the individual observations then is my guess.
Yeah.
Yeah.
Okay. Well, I will turn in our podcast or whatever this is called.
Okay. Yeah.
Okay. Alright. See you guys.
Later. Have a good weekend.